Very good evening, everybody. Welcome once again to all the regulars, and welcome to all the people who are watching this as a recording. Who could not, connect at 6:30 for, I'm assuming, various other pressing important engagements. But thank you for connecting at least through the recording. All right. So before I begin today, I'll just like to read out a very interesting WhatsApp forward. I hate WhatsApp forwards, but today I'm making an exception. I'll just read it out. Okay. So this is the message. Today morning, 8 a.m., I received a phone call. Good morning. Are you hungry, sir? Was the question asked. Yes, I said. Actually, I was hungry as I hadn't had my breakfast yet. But why you asked? I asked the caller. The reply came, it is part of preparing data for Global Hunger Index. Thank you for your response. Data science is a very, very powerful tool, all right? And data scientists should be deserving to use that tool. And that is the premise by which we are having these discussions. What is all this? Some feedback. You are talking about the fundamentals. When are you going to jump into core programming in Python, etc.? Everybody wants to, straight away, fly the F-16. They don't want to learn to ride the cycle. All right. In fact, F-16 directly, we want to fly. So this seemed quite apt. All right. So on that note, and also to satisfy the requirements of some people who feedback, when can we start with model building machine learning? We are today starting our discussion on model building. All right. So again, the participants, all the audience who are attending, I'm assuming most of them have done some form of training whatsoever. So we will not be going into some fundamentals like name the types of machine learning models. I think we'll skip that. Rather, I would jump into, like I said, on the project basis and ask Sharath, among the types of machine learning models that are there, which is it that you predominantly used in the project that you had worked on?
Thank you, Nitin. As usual, good evening, everyone. Welcome to the channel. And I hope you all are taking advantage of these sessions and sharing the information, sharing the news with your friends and family members. Coming to the question, what are different types of machine learning models that we can try and use, or predominantly for me, what is the favorite? For my project, I'll again go back to the automobile industry fuel efficiency prediction model that I have worked on. And as part of this particular model, of course, I had built the regression-based techniques, which are under the prediction or supervised learning techniques, because that's what business requirement was. But for your question, I would always say that once the EDA part is done, which we discussed in our previous videos, you can go to the links below and then go through the previous interview sessions. You would understand and appreciate on how important these EDA is for any data processing. And we basically talk about univariate analysis there. But when we talk about data science and when we are trying to understand the information from the entire data set, then we need to also look at the relationship between the variables, right? So I'll just upgrade my univariate analysis, and this time I would be trying to do multivariate analysis, right? So I'm basically not sticking to one column, but I'm going to sticking to multiple columns. And together, what kind of information can I extract? Now here, when we try to do multivariate analysis, of course, we will have to use certain techniques, and I personally call them as the unsupervised learning techniques. Different people might have different opinion about this, but under the machine learning modules, unsupervised learning techniques are going to be very pivotal and critical for getting the right information for even for your prediction models. In my case, the automobile scenario, the fuel efficiency case, We basically performed the algorithm called as clustering, which is unsupervised learning technique. This actually helped me to get the variations reduced in my data set. So homogeneity is something that we wanted to extract. And post that, we went into the supervised learning techniques. So to, again, coming back to your question, my favorites, obviously, I'll first go with unsupervised learning techniques, because unless until I understand what information I'm dealing with in the data, there's no point going into predictions. So unsupervised learning techniques are my favorite, but eventually we will have to go for machine learning prediction techniques.
Thank you, Sharad. Thank you. And friends, that seems to be the logical path. Unsupervised most often times comes first, is what it is. So there's nothing really different. But I would like, Barney to answer the same question. But I want Barney to take a different take on that with reference to the rationale of choosing unsupervised or supervised. What was the rationale and how did you go about making that selection?
Sure. Thank you, Nitin, for asking that question. And like Sharad has rightly pointed out, yes, we need to first look at the opportunities of implementing unsupervised learning techniques, especially clustering. And post that, we determine what supervised learning techniques should be applied on each of the clusters or each of the segments. On our project or on my project that I worked on, it was pretty much the same scenario wherein we first looked at the entire data. And when we looked at the data, we figured out that, there was a lot of variance in the data, in at least the numerical columns. A lot of variance means there's a lot of heterogeneity in the data. A lot of heterogeneous data, wide variety of data was coming in. When we have applied clustering on that, we figured out that we got different clusters or segments. One segment was pertaining to, this project, if you remember, was related to heavy construction equipment loan. And who are the people who might default? And who are the people who might purchase or who might take a loan for purchasing heavy construction equipment? It can be small players, startups in the space of construction, or probably real estate agencies. Okay. And then maybe heavy construction equipment, companies which extensively invest in construction. So when we have done clustering or segmentation, we figured out that there were three key segments. One segment was rookies in the space of construction. Another segment was related to real estate folks. And within real estate, people who are mid-sized was that segment. And the third segment was real estate people who had a very large scale. And once we got these homogeneous segments, then when we applied our prediction models on each of these segments, on one segment, one supervised learning worked very well. On another segment, a different supervised learning technique worked well. And on the third segment, altogether a different, supervised learning technique worked well. So given this context, rather than painting everything with the same brush or everyone with the same brush, we have done this segmentation or clustering, and on each cluster, we apply different prediction models. And that is how we need to proceed further when it comes to model building.
Thank you, Bernie. Thank you. So audience, if you notice, both the experts have mentioned about clustering. Now, remember, these people have done hundreds of projects and interacted with clients, etc. Not everybody may have had a chance to have the kind of experience that these two have had. Oftentimes, even in mock interviews that I take, many people respond by saying that, did you do, even if I ask them, did you do clustering? They say no. Now, you would do clustering only if you have a considerable size of data. You wouldn't do clustering for 50, 60, 100, 200 records. If you do clustering, let us say if you do 3 clusters for, let us say, 100 records, you're going to get an average of 30, 35 records per cluster. what model are you going to build with 35 records? Now, the 35 records need to further get partitioned into train and test. So if you have not really worked with large data sets, only then you wouldn't have clustered. So therefore, if you are not responding, if you are not mentioning clustering, an interviewer will immediately know that you have just worked with some Google data sets, some small size data sets, and done your project. You have actually not had experience in that. So that is an important litmus test which the interviewers will know with reference to that issue. All right. So I just wanted to add that the tidbit of information there. So Sharath and Barney both, I've heard, I know most of the people we have heard about only two. All right, supervised and unsupervised. But we hear that there are other things as well. All right. So could you just tell me what they are? Sharath, you could probably start. Tell me what they are and probably just give some definition about what is that.
Thank you, Nitin. Yes, I would love to answer that question. But before I jump into your question, I just wanted to add some more points or at least a couple of points from where you have left explaining about the clusters to our audience. The important point, yes, rightly said by Mr. Nitin, that when you do not have large data sets, you probably would have not experimented by doing the clustering. A lot of people, they just keep it aside because ultimately when you do the clusters, your data set comes down to a small number. And on top of that small number of samples, you would definitely not really enjoy working on because your models will not understand the patterns. But saying that, as part of your descriptive analytics or multivariate analysis, I would personally recommend you all that irrespective of the size of your data set, to understand the information that your data has, you always try and do this clustering as a random practice, just as part of your EDA, how you do univariate analysis. Just ensure that you do clustering. It hardly takes time, right? If you are familiar with the code and the logic, it hardly takes time to just do that clustering and try and understand what each group has to say. Of course, when you're trying to build your prediction models, proceed with the entire data set as a single data set if you have limited quality or limited quantity of the data. But as I said, try and do clustering or any unsupervised learning technique because ultimately it describes the data better. This is one point that I wanted to add on top what Nitin has mentioned. Coming to the question on what are the different types of the learnings, right? The machine learning algorithms are categorized into. I'm pretty sure majority of you people have stuck with unsupervised learning and supervised learning. This is because you have only studied these things, right? Probably in books or probably the trainings that you had or probably the learning curve that you had limited access to the content or you're just starting. So you probably will try and stick to supervised and unsupervised. But there are other techniques like semi-supervised, which is predominantly applied subconsciously, even without your knowing that you're applying semi-supervised, you sometimes apply that. We have reinforcement learning. We have self-supervised learning, we have transfer learning, right? So there are different types of learning algorithms out there. Now, I would definitely like to add the definition of semi-supervised in a way that you can easily understand. So let us assume that there is a data set where you don't have the variable of interest. We call it as labeled data, right? So when you don't have a labeled data or variable of interest, there's no way you can actually build a supervised model, that is prediction models, because you need a historical data to develop a kind of a mathematical equation which can explain the relation between your input variables and the output from the historical data. But here in this case, the example that I'm taking, you don't have a label. Now, in such case, again, we go back to unsupervised learning techniques, for example, clustering. This cluster exercise can give you the cluster ID, and that cluster ID can become your label. Once you identify this label, right, you can try and proceed using supervised learning techniques by considering the cluster ID as your output variable. So this is basically allows you to also come up with your right prediction models on a data set where you don't have a labeled data. This is semi-supervised learning techniques. Of course, unsupervised is predominantly used for descriptive analytics where you don't have a labeled data. Supervised learning techniques are basically used for doing prediction models where you have labeled data. Reinforcement learning is another technique that basically is used for, you say, reward-based learning, or you can also call it as penalization-based learning. If the agent does the right thing, then the model gets points. You can say it's like a video game where the agent hits the right point, then it gets good points. If it is not doing the right thing, then the player dies in a video game, right? So it's kind of reinforcement learning. By doing multiple times, the algorithm will learn. And we do have other techniques as well. I just don't want to capture the entire time here. So
yeah. It definitely gets a little, we get a little animated when we are in our favorite zone and in our comfort zone. We want to tell more about it, especially from our experience. So I could make that out. So, but we'll try to, get back to the focus with reference to the types. Predominantly, what we are going to discuss is the types and how it works. We'll be sticking to that. And then if time permits, we'll move into some more depths of it. So yeah, Barney, the baton is passed to you. So apart from the usual supervised, unsupervised, what insights can you give with the remaining types of learnings with your experience?
Sure, absolutely. So before that, I want to first quickly give one-liners for supervised, semi-supervised, etc., so that when I talk about self-supervised learning and probably reinforcement learning, people will understand better. In supervised learning, within the historical data, you will have the output variable and input variables. You will have the target or label and the features. In my project, we wanted to predict whether a person will default on the loan or not. That was the output variable, target or label, different names for that. And we had a bunch of inputs such as age, gender, income, so on and so forth. Features. In unsupervised learning, wherein we applied clustering, in that we started treating this output variable as another feature. And then we built clustering algorithm on top of that. Because for unsupervised learning, the output variable is unknown. Even if you have the output variable in your data set, you mimic as if that's one of your features, inputs. Then we have semi-supervised learning, wherein within the entire data set, for example, if you take image-related business problem, one of the cancer prediction models that we have built, in that we had close to 6,000 images. Out of that, for 3,000 images, we had a label, whether that particular image was malignant or benign, whether there was calcification, right? So on and so forth, whether it was fatty benign, fatty malignant, and a bunch of other classes were there. For 3,000 images, we had the labels. For another 3,000 images, we did not have the label. We had to either hire a radiologist who would probably charge, I would say $100 per hour. And just imagine in 100 hours, probably that radiologist would be able to label 5 to 6 images. Given that we had 3,000 images, it would have been a huge investment for us just to give labels to the images. Hence, what we have done is, using the 3,000 images which we had, for which we had labels, we built a prediction model on that. And once we built the prediction model, we applied that onto the remaining 3,000 images. And we had the predictions of all the 3,000 images on whether the image was malignant or benign, etc. And then we combined all of these 6,000 images to build one comprehensive model. So the usage of semi-supervised learning here is to just get the labels for the data where we did not have the label. This is semi-supervised. Then we have self-supervised learning. Self-supervised learning means from your inputs, you try to learn your inputs. Okay, what do you mean by that? If you take an example of NLP, natural language processing, given the text, given the words, some words might be missing for whatever reason. Maybe when you scan the document, it didn't figure out that particular word properly. Maybe there was a blank space or whatever might be the reason. So your NLP would learn those words, which are your inputs, and it will predict the missing words. So inputs are taken to find out the inputs. That's self-supervised learning. And then you have reinforcement learning. Within reinforcement learning, if you have huge number of rules, for example, I'm sure a lot of people invest in stock market. Should I invest in Google or should I invest in Microsoft or should I invest in Facebook? How many units of stock do I purchase on Facebook? How many do I sell pertaining to Google? How many do I need to retain pertaining to Microsoft? In that way, you have thousands of companies which are being traded on stock market. Where would you invest? At what time would you sell? How much quantity would you sell? How much quantity would you retain? Oh my God, it would be a Herculean task. In these kind of scenarios, you resort to reinforcement learning, where you just define an objective function. What is your objective when you invest on stock market? Obviously, you want to become Warren Buffett, right? Or Rakesh Jhunjhunwala. And obviously, your objective would be to maximize your profits. So you just tell to your reinforcement learning that I want to maximize the return on investment. For the money that I'm investing in stocks, I want to increase the return on investment. That's it. And reinforcement learning would learn all the patterns. Okay, at this time period, you sell these many stocks. At this time period, you purchase these many stocks. At this time period, retain, don't do any trading. So all these rules, which otherwise are very daunting, would be learned by a reinforcement learning. So that's how it's going to work.
Thank you, Bernie. Thank you for that elaborate answer. So I'll now get into the, deep dive into the various types of machine learning, and specifically with reference to supervised, because we've already discussed about unsupervised and clustering. So Sharath, question to you. You've decided to go ahead for supervised learning. Now, amongst the supervised learning, the choice that you make, what are the factors that comes into play for making that decision?
Yes, Nitin. Thank you. So after unsupervised, of course, we will have to do supervised learning because of my business requirements were asking to do a predictive problem solution. So when we come to the supervised learning, of course, any algorithm that you want to use, the first point is interpretability, explainability. So from that perspective, of course, the first choice would always be statistical based algorithms rather than going into the black box methods. Of course, the black box methods gives us a better result and better flexibility. But we do have alternatives with respect to the statistical based approaches as well, or explainable models as well. The simple rule, of course, is we need to look at what is the target variable that we are trying to predict. Right? And ultimately, we have to develop a mathematical equation, which is, of course, explained as y is equals to f of x. Now, if I have to build this mathematical equation, and if I know the output variable y that I need to get is the numeric value, then I will resort to regression technique. And that's what we have done in our model, because I had to predict fuel efficiency. And when we go to the regression variance, we do have the most popular linear regression techniques, because that's what we were trying to predict, the continuous output. But we also had experimented with various tree-based regression algorithms, because those are, of course, giving us a lot of flexibility to do hyperparameter tuning to improve the accuracies and all that. If you permit me, if you have time, then I would like to elaborate this. But yeah, if you let me to do that.
I think we'll extend this topic to maybe tomorrow as well. But I had one question that I'm, thinking from the beginning once I got it done, and I want Arni to, give the explanation for that. So we've heard recently about something called as self-supervised learning. So could you throw some light on that, Barney, what it is, and if any, by chance, you've had any experience with that?
Yep, absolutely. So I think I've already answered that, but nevertheless, I'll answer that once again. In self-supervised learning, you learn your inputs from your inputs. What do you mean by that? So for this, classic way of explaining this is to talk about NLP, natural language processing, wherein you have text. Okay. If you have a huge corpus, say from Wikipedia or from any other known source, and then if your model is reading that text, it will be reading and understanding how to formulate a sentence and things of that kind. And if there are a few other documents or sentences which are incomplete or maybe have certain words missing, then your model already would have learned on your inputs on how to frame the sentence. It will automatically fill those missing words for the documents where certain words are missing. So learning inputs from inputs is called as self-supervised learning. So you don't have any labels out there with which your model can learn. Given your data itself, it would learn, and then it would try to fill the missing values within your data.
So is it a follow-up question, Barney? So is it something that only works with some kind of sequential data, text NLP or something like that, or it can be extrapolated for cross-sectional data as well?
Yeah, it can be extrapolated to cross-sectional data as well, and also time series data. Absolutely.
Thank you. Thank you so much for that response there. So we have just a minute. So coming back to you, Sharath, you wanted to explain a little more about that. So maybe you could probably use this time now.
Yeah, 2 minutes. All right. So when we talk about the explainable models, my favorites are tree-based algorithms, because they give us a lot of flexibility, as I mentioned, with respect to tuning the algorithm. Any model that we implement by default is basically called as a vanilla model. We don't experiment with a lot of options or parameters that we implement on these data points. So once the data is prepared, we pass that data to the models, and we see what this base model is resulting into. Once we evaluate the models, we will again further try to improve the model by tuning the parameters. Each algorithm has its own set of parameters, and tree-based algorithms are my favorite because it gives you a lot of flexibility. In fact, I would say unlimited flexibility. So yes, it is my favorite, and as I said.
Yeah. So on that note, I'd like to close this with a little bit of an argumentative. Me and Sharath have been arguing this for many years. So I argue that a tree-based model, specifically a tree-based model, is just a rule-based model. It is not really machine learning. This has been, and we have had a lot of animated discussions on that. It is just a set of rules. You pass your data through that rule. Where is the learning? All right. And yeah, the jury is still out. We have not yet taken a decision. But ultimately, if you look at it in the perspective of, getting the output and with reference to accuracies, etc., no doubts, tree-based models have proven to work well for a variety of types of data, etc., for classification predictions. More about that in subsequent sessions. We'll wrap it up. Thank you so much, friends, for consistently joining with us. I see a lot of regulars, waving. So yeah, hi to you all as well. And please continue to join us and do spread the word. Thank you so much.
Yeah, discussion should be on. Looking forward. Thank you all.